So this video is going to combine elements of some of the other videos that you've seen. If you recall, if you recognize this one plate right here, that was our colonies that we picked. I did isolate the plasmid and sequence them. The NS4A were good, but those NS2A, they were not the right thing. So I'm going to go and do a little bit more work and do what's called a PCR screen. Just to show you once again what a really nice grid plate looks like. Look how pretty these are, but that's not my style. I use the ugly number on the back method, right? It works. It is not as nice, and certainly if I need to pick way more clones, then I'm gonna do a proper grid. For this PCR screen, we're gonna do something called colony PCR, or sometimes called dirty PCR, because it turns out to get PCR quality DNA, sometimes all you really need to do is take some bacteria and boil them in water. If I have a grid plate that already has a lot of bacteria on it, I will pipette 400 microliters of water, like 5 through 10. I'm also going to pick some fresh new colonies, and for those I use 200 microliters of water, because generally you don't get quite as many cells from those. To be honest, I don't think it matters too much. It's just kind of what I do. And it's been working for me, so I'm going to keep doing it. Prior to recording, I already put 400 microliters of water in the other tubes, so I'm ready to start picking. Get some sterile toothpicks. Make sure your hands are sprayed with ethanol, because that's the way I like to do it, remember, which I've already done. And then simply touch the toothpick to the culture and plunk it in the water. And it's helpful, and I don't always do it, but it's helpful to put your finger on the culture that you're going to go and pick, and then simply pick it. And repeat for all of them. Notice finger and pick. I also want to pick a few more clones, just in case those 6 over there don't have it. So for this, relatively similar to when I picked colonies before, pick a nice, well-isolated colony. Little line on the plate. So I make sure that I have a culture just in case. So I'm going to need it for plasma preps or whatnots. And go through that process. And what I'm going to do is I'm going to pick 4 from here. So then I have a total of 10 for me to do a PCR screen on. And then I'm just going to fill the plate just in case these all happen to be negative. And I want to go back and I do some more. But, to be honest, the type of cloning I'm doing is pretty high efficiency. If I don't see it within these, what will end up being 14 total, I probably don't have it, so I might not waste my time, but I always like to have the luxury, and I still will keep these plates just in case, so then I can continue to screen more if I want to. Once you have your clones picked, you're going to need to knock them off the toothpick, so we use a vortexer for that. I just pulse it, bunching back and forth. Sometimes I'll twizzle a little bit, so you take the toothpick in your hand and just kind of roll it around back and forth, and then pulse. You can pulse 1 at a time, or you can pulse 2 at a time, whatever you feel like. Sometimes when you have a lot, it's much more useful to do 2 at a time. But if you want to be careful, do 1 at a time. Just make sure that you don't just hold it down the whole time, and be careful that the liquid doesn't fly out of the tubes and make a big mess. And once everything is prepped, then it's time for the boil. There is often a thing where the liquid around the edge of the lid will cause the lids to pop open, and sometimes the boiling water will flow in. So these little snappy thingies, I don't know what they're called, will help prevent that from happening. So add one of these snappy thingies to your lid, place it in one of these racks, and then into the boiling water. Make sure that the boiling water reaches to the bottom of the tube, and we boil 5 minutes. Hey Siri, set a timer for 5 minutes. And then once the 5 minutes are over, turn off the water, take the tubes out, place it back on your rack, and then you can take that with you to the bench. Be careful, of course, things are still a little bit hot. That's why they got these little handle things on top of the lid, and whoops, one came off, and you can try to put it back on, or just like, whatever, it doesn't matter. Cha-chang! And back to your bench. And we're ready to set up our PCR. Now, here comes an advanced skill. I have 10 reactions. I could set up each one of these individually. But you also have to recognize the fact that each of these 10 reactions is going to have the exact same thing, same tack mix, same water, same buffers, same primers, except the DNA will vary. So what we can do is we can actually make a master mix that contains everything that I need, then I can simply aliquot it out into these 10 tubes, and then add the DNA separately to each one. It's much more efficient this way and prevents a lot of pipetting errors. So I've already started a mix. I just need to add the second primer now. And that's the last element that I'm going to add to my mix. And then you can actually kind of see the tube. It's already sitting on ice. Labeled mix. There it is backwards. And then give it a really good flick mix. You want to make sure that everything is mixed well. Because remember, if it's not mixed well, the reaction won't work. And then centrifuge to settle everything down. So you will learn how to calculate the amount of each reagent to put in the reaction mix. Just remember, it's always going to be multiplied by the amount of reactions that you have plus 1 because of some pipetting loss, right? So in this case, my master mix is going to have enough for 11 reactions because there's always going to be some pipetting loss. Now, I'm going to pipette the common mix into all my tubes. And then I will add the DNA afterwards, right? So this allows me to use one pipette tip. Again, it's much more efficient this way. It's very fast. And then I simply take my DNA and start pipetting my DNA. Notice, by the way, I'm setting up my reactions on the bench. And that's okay because the type of polymerase we're using is called a hot start TAC. It's a TAC polymerase. The hot start feature is this inhibitor that prevents the enzyme from being functional until we run it through a heating cycle. So this allows you to work with it at the bench without worry of any non-specific reactions. Makes it much easier to handle. Not all our polymerases are going to be a hot start. So just be aware of that and just note. Sometimes you can do it on the bench. Sometimes it should be on ice at all times. Once you've mixed the DNA, we do a flick mix like we always do, making sure that all your reagents are well mixed. You can do it 1 tube at a time. You can do 2 tubes with each other. You can do a single flick. Whatever works, whatever you feel like doing. Lots of different options. There's no one way to do it. And then, of course, after the mix, centrifuge. The switch for the thermocycler is in the back right corner near the power line. Flip it on, open the lid, and then place your tubes into the appropriate spaces. I like to space them out. Sometimes because the lid weighs down really hard to prevent any heat from leaking, sometimes it ends up crushing your tubes a little bit. The next time you open this, there might be a little bit of spacers. We'll see. And then just a gentle push to make sure the lids are nice and closed. There are preset programs on our thermocycler. Simply hit Open Method, find Bio275 Lab, and then we're going to use a standard 3-step PCR. This one will work for most of the type of PCR that you'd like to do, but we can make some adjustments. So for example, one of the things we may want to adjust is the extension temperature and length of time. It's definitely not going to be this long ever, but you should have a discussion prior to determine what settings that you'll need to use. A lot of these are going to be primer dependent and template dependent. And then once everything is ready, simply hit next and then start run. And then you can track the run as it goes. It'll tell you the current temperature and the stage of PCR that it's in. And finally, when the PCR reaction is done, you'll see the 4 degrees Celsius. That's fridge temperature, by the way. Just simply hit the middle button, tell the run to stop, and then we're good to go. Simply open up the lid. Notice that the tubes are bent just a little bit because of the weight of the lid. Grab your reactions out, and then these are ready to load on a gel. And because I know you're dying to find out what happened on the PCR screen, let's take a look at the gel. When looking at a gel, it's important to orient ourselves a little bit. We need to know what the amplicon size or the PCR product size should be, as well as how big the pieces that we're actually looking at. So the bands that you see on the far left are the DNA ladder, and these are pieces of DNA of known size. So then we can compare the size of our amplicon or our PCR product with the DNA ladder itself. Now, we need to know how big our amplicon should be, and our amplicon should be about 850 base pair, give or take. And so looking at the ladder, we can see that this band is 750 base pair, this band is 1 kb or 1000 base pair, and you'll see that our applicant fits nicely in between. So I would consider this a successful PCR. Like I said, it was a high efficiency cloning, so I'm not really sure why the first 4 didn't turn out this way, but I'm very happy that the rest of these are positive clones. So yay!